In this video, we want to review the basic operation of private VLANs and talk about how we can troubleshoot private VLANs. Let's begin by reminding ourselves why we might need a private VLAN. Let's say that we've got an office building much like this, and maybe the IP address space is divided up such that every floor has its own subnet. We've got a /24 subnet on each floor, and let's say that on floor 15, every device on that floor has an IP address in the 10.10.150.0/24 subnet. And we'll say that that's VLAN 150. But the challenge is, in this office building, it's possible that we've got different companies that just happen to be on the same floor. Maybe one office is for one company, maybe another company has a few offices on that floor. What we want to be able to do is allow those different offices from different buildings to have some isolation from one another, be in different broadcast domains, even though they belong to part of the same VLAN. How can we do that? We can use private VLANs. And to understand private VLANs, there's some terminology that we need to talk about. With a private VLAN, we have a primary VLAN. It's VLAN 150 in our example. And we can take this primary VLAN and subdivide it into different domains. And we've got a couple of different types. We have community VLANs. This might be useful where we have more than one port on a Cisco Catalyst switch that needs to belong to the same broadcast domain. Maybe we've got different devices on the same floor of a building. They are part of the same company. We want them to be in the same broadcast domain, which might be a good thing for printer sharing as an example. Well, we could place those ports in a community VLAN. Maybe we had another port and it needed to be by itself. We could put it in an isolated VLAN. And let's say in this example, the primary VLAN is 150. We've got a community VLAN that's going to contain a couple of ports, and it's going to be VLAN 151. We've got an isolated VLAN of 152, and let's say that we've got another isolated VLAN of 153. And please understand, even though these are in different logical broadcast domains, the community VLAN and the isolated VLANs, they can still talk to one another through traditional layer 3 routing like we would get between VLANs normally. It's just that they happen to be part of the same IP address space, and they are logically isolated at layer 2. Let's think about what this might look like on a Cisco Catalyst switch. I've got a Cisco Catalyst 3750 here in the studio, and it's configured for private VLANs. I'm using the first 5 ports on this switch, Fast Ethernet 1/0/1, all the way through Fast Ethernet 1/0/5. And I'm saying that Fast Ethernet 1/0/1 is a special type of port. It's a promiscuous port. And a promiscuous port is going to be able to communicate with the other subdomains, with the other VLANs within this primary VLAN. In other words, Fast Ethernet 1/0/1 on this switch, it can communicate with members of the community VLAN of 151, the port that belongs to the isolated VLAN of 152, and the port that belongs to the isolated VLAN of 153. Let's say the next couple of ports on this switch, Fast Ethernet 1/0/2 and Fast Ethernet 1/0/3, let's say that they belong to the community VLAN of 151. They will be able to communicate between themselves. They're in the same logical broadcast domain. And of course, they're going to be able to communicate with the promiscuous port, but these two ports, they're going to be community ports. Next, we have Fast Ethernet 1/0/4. It's going to belong to the isolated VLAN of 152. And this isolated VLAN, it's isolated at layer 2 from the community VLAN of 151. If I needed to get from this isolated VLAN to the community VLAN, I would have to route in order to do that. But again, the isolated VLAN, it can communicate with the promiscuous port. Same thing for the port that belongs to isolated VLAN 153. It's isolated from 152 at layer 2. It's isolated from 151 at layer 2, but it can communicate with the promiscuous port. And this promiscuous port, because it can communicate with all of these subdomains, that makes it a great candidate to be an uplink port, maybe to a router. And let's say that we've got a couple of laptops that belong to company A. Well, because they belong to the same company, they might connect to a community VLAN. These two company A laptops, they can communicate between themselves without having to route. They belong to the same broadcast domain. Let's say we've got another laptop that belongs to the isolated VLAN of 152. We'll say that's a company B laptop, and we've got a company C laptop, and it's connecting into the isolated VLAN of 153. And when it comes to troubleshooting private VLANs, we typically have one of two issues. The first issue is we've got a couple of ports that are able to communicate with one another at layer 2, and they should not be communicating. Or the other issue is we've got a couple of ports that should communicate at layer 2, and they're not communicating at layer 2. For example, the two company A laptops are not in the same logical broadcast domain. They're not able to communicate with one another. Or maybe the company B and the company C laptops, they can see one another at layer 2. That would be a bad thing. And normally this just boils down to a private VLAN misconfiguration. The first thing we need to understand to troubleshoot private VLANs is what we just talked about. We need to understand these different roles. We need to understand the concept of a primary VLAN and its subdomains. The community VLANs, the isolated VLANs, we need to understand the concept of a promiscuous port. And once we understand that theory, we can give a couple of show commands to determine how our switch is currently configured, and hopefully spot the misconfiguration. Let's go out to this Cisco Catalyst 3750 and give some commands to determine how the private VLANs are configured right now. We're sitting on switch SW1 and we're trying to verify that our private VLANs are configured as expected. One of the first commands we might give is show VLAN private-VLAN. And this tells us that we've got a primary VLAN of 150. That's our primary VLAN. And then we've got these subdomains, these secondary VLANs. And we see that 151 is a community VLAN. We can have more than one port belong to that community VLAN. But then we've got 152. It's an isolated VLAN. 153, it's an isolated VLAN as well. And let's do a show run pipe to begin 1/0/1 so we can take a look at the actual interface configurations. Notice for interface Fast Ethernet 1/0/1, I'm saying that this interface is running in promiscuous mode. And I'm doing my private VLAN mapping here. I'm saying that I'm going to take the primary VLAN of 150 and associate with that the secondary VLANs of 151 all the way through 153. For Fast Ethernet 1/0/2 and 1/0/3, those two ports belong to the same community VLAN. And notice instead of saying that the mode is promiscuous, we're saying that the mode is host. We are connecting out to hosts on these ports. And the host association is we are associating with the primary VLAN of 150, but the subdomain to which these hosts belong, their VLAN, it's 151. Similar configuration for our isolated ports. Fast Ethernet 1/0/4. Again, we're saying the mode is private VLAN host, and we're associating with 150 as the primary VLAN, and we're in the subdomain of 152. And Fast Ethernet 1/0/5, it's also in the mode of private VLAN host. The primary VLAN is still 150, and we're in the subdomain, we're in the logical VLAN of 153. And based on our topology, that's what we want. And here's another command we might use to get this type of information. We can say show interfaces, give an interface identifier. I'll say Fast Ethernet 1/0/1, and then give the keyword of switch port. And this can tell us, and this is our promiscuous port, it can tell us that our administrative mode is private VLAN promiscuous right now. And notice the private VLAN mapping. We see our primary VLAN and then all these subdomains, all of these secondary VLANs. And this port, because it's a promiscuous port, it can communicate with all of those VLANs. Let's take a look at a port, though, that's not a promiscuous port. Let's take a look at Fast Ethernet 1/0/2. This time, we don't have a private VLAN mapping, we have instead a host association. We see that we're associated with the primary VLAN of 150, and we belong to the secondary VLAN of 151, and you can see that our administrative mode is private VLAN host. We're connecting out to a host. In this case, it's a laptop belonging to Company A. That's a look at a few show commands we can give to better understand how our private VLANs are configured right now, and hopefully we can spot any misconfiguration that might be causing a couple of ports to communicate that should not communicate, or a misconfiguration that might be preventing communication between a couple of ports that should communicate.